We would like to thank all parties for standing by and to advise you we have placed your lines on listen only until the question-answer segment of today's conference. At that time, to ask a question, you will press *1 on your touch-tone phone. This conference is being recorded. Should you have any objections, please disconnect at this time. I would now like to turn the call over to Rennie Shen.
Thank you, Rianne, and good morning, everybody. So once again, my name is Rennie Shen, and I'm a Product Marketing Manager with F5 Networks. And with me is AJ Mahajan, Director of Product Management at NetApp. So we have some great content available for you today. We're going to talk about strategies for a seamless and secure transition to enterprise cloud storage. Cloud storage is a hot topic on everybody's mind today. What is it? How does it work? And how can I leverage this technology most effectively and most efficiently to meet my business needs? First, we're going to hear from AJ. He's going to take us through the basics of cloud storage for the enterprise, as well as how NetApp can help us all out in this space. And then I'm going to talk to you about how you can deploy cloud storage in your existing file storage environments in the most seamless manner to maximize some of those cost savings that cloud storage can offer. Now, one quick comment on logistics. At the end of the presentation, we're going to open up the line for questions, so please stick around and we'll get all of your questions answered. So without further ado, AJ, how are you doing today?
Hey, I'm doing fine, Rennie. Thanks. So thanks for having me on the call today. So good morning to everyone. And what I'm going to do is first walk through some of the concepts and overview, a very brief overview of what enterprise cloud storage is and what NetApp has been doing with it. And then we'll walk through some of the implementation details, how it helps you solve various challenges that you face. So getting into it, and I will walk you through these concepts. So the main thing is when planning the move to cloud computing, there are a whole bunch of business and technical challenges, right? And what happens is going through some of the top cloud barriers, and then we will get to the hype versus what is reality, what works, what doesn't, those details also. So the main thing is as organizations grow over time, whether organically or through mergers, acquisitions, and all that, they end up having to manage and run multiple hardware architectures. And these multiple hardware architectures in turn lead to multiple management interfaces. And then what happens is that actually not only is multiple architectures, but multiple management tools, panes of glass on top of it. That then leads to more and more complexity. At the same time, whether you have completely standardized on one single IT vendor, even then you still have multiple technologies, multiple products, all of these things. And if you are using in various areas best-of-breed technologies, then the whole cloud stack, when you look at it, that has a lot of diverse parts. And then as we have seen, cloud computing over the last 2 years, especially over the last 12 months or so, it has really moved from industry hype to a top IT initiative for most of you. So why NetApp? And I'm going to just get through kind of the high-level concepts here, and then we'll dive through the details shortly. So one is NetApp offers a complete set of capabilities for storage and data management, all within a single unified storage architecture. So these are not different disparate things, but a single unified platform allows you to do all of these multiple things. And then the second thing is our on-command suite of management that provides automated, consistent, and repeatable and reliable storage provisioning as well as storage management through the complete life cycle of data. And then what has happened is since no single vendor can address all of these things, you want to make sure that there is a very robust partner ecosystem, and today's webinar is actually an example of that, how NetApp and F5 have worked together to offer this enterprise cloud storage solution. So what we need to make sure is that your vendors and providers, they are helping you on your path to the cloud, including cloud management, cloud infrastructure, working with cloud SIs, service providers, all of these. And then the main thing is field proven practical implementations. So what that means is that NetApp working with partners has really helped many industry-leading enterprises, service providers, system integrators to evolve to a service delivery model. And that is really using storage solutions as the foundation for deploying these clouds. So now let's look at how things have changed over the years. There is a lot of talk about public cloud versus private cloud and kind of the dedicated architectures and how all of these things really fit together. So the two things, right, that IT organizations and the IT management they are being asked is to either embrace service provider model and kind of offload some of their non-critical or non-mission critical type data applications onto service providers, or transform their own internal operations to match the responsiveness and the economics of external cloud services. So the question that now we have to ask, right, is not if we are or if you are going to move to cloud computing, but really how, right? So how we are going to move to cloud computing. So let me put public cloud versus private cloud versus dedicated architectures, how all of these things depending on your applications, how everything works and what happens, put that into context, and then we'll run through some examples on that. So looking at this is really the transition. So from left to right, how most IT organizations, your deployment started and where they have been evolving to, right? So the main thing is the application-based silos, right? So that has been the primary provisioning model for servers and storage up until last few years. And this application-based design approach that started with individual applications, and then how do you deploy a dedicated infrastructure to run these with services and storage carved out for just those applications and their users. And then what happened is over the last 4 or 5 years, the server virtualization that completely changed the whole landscape. And what that did was that completely different architectures, applications, all of those could be deployed on a single pool of resources, and those can be shared across multiple clients. And also what virtualization allowed was really decoupling of the application from the physical resources or the hardware that these applications were deployed on. So applications became mobile. They could be moved around from server to server or for load balancing, provisioning, those type of things. That in turn caused a lot of interesting challenges for underlying storage and networking, especially when these can be moved from data center to data center, either for disaster recovery or they can be moved off to a cloud hosting type external model versus brought back in. And now what is happening is as virtualization has become mature, your deployments, most of them have resulted in higher degrees of virtualization. Then the question is how do you maximize sharing across all of this common infrastructure and then add automation to that as well as self-service mechanisms. And that's what has led this to being called cloud, where you can actually share these across common infrastructure, use automation, and use self-service mechanisms, whether it's a portal or a request mechanism. And then it is a private cloud if it's built inside an enterprise to run your IT as a service, or leveraging external public cloud offerings to complement either your internal standard resources and infrastructure or for various different as a service type model. And basically the intent is this would allow to lower IT costs and gain operational efficiencies across the board, and you can be flexible, right? So that is the thing. So what we believe is that all of these multiple different models, they will coexist for quite some time, and that's where we have to figure out that what works with what is a good candidate to move to one of these models, and how you can do that in an efficient manner, right? So this is a kind of 2x2 chart. So I'm going to walk you through this. So we are on the previous slide. So application silos, private cloud, public cloud, how the evolution happened. So what you see here is on the horizontal axis, it's really the strategic value of applications. So everything starts with applications, right? So you have to look at your applications, really evaluate their strategic value. And the more strategic they are to the right, and the most strategic ones, if they are really strategic, really critical, then you are prone to or more likely to keep those in-house. On the vertical axis, what we see is the operational flexibility, where if there is more flexibility is designed, whether it's from provisioning or overall management or from the expense structure, then it would lend itself more to a cloud deployment model. So again, to make sure, if there is lower strategic value and higher flexibility, then these applications would be good candidates for deployment on public cloud. And these are not steadfast rules, right? So depending on your individual situations, these things would vary. Some of the software as a service applications we know are highly strategic. So this is not as a rule that applies to everything, but it's a general guideline. Same way, if there is lower strategic value and lower flexibility, then those are really excellent candidates for virtualization, and that is what really started the initial popularity of virtualizing of all the infrastructure apps, right? So that's what we saw happening about 3 to 4 years ago. And then looking at the upper right side, so higher strategic value, higher flexibility, so that would make a pretty good argument for bringing, or actually for building a private cloud in-house and keeping these strategic applications in there, and also realize the benefits of cloud, right? All the flexibility and the economics that you see there. And then the other side there, the application silos, that's as I started with, higher strategic value, lower flexibility. So that is a really good key argument for keeping something in an application silo. Could be very big, complicated legacy applications. So those type of things, or the operational model or the workload is very well defined, not too dynamic. So those are good to be kept as is. So that kind of summarize, right? So how does this now help you drive your strategy as to how to deploy all of these things together? So the main point of this slide, so this is a chart we saw earlier, the horizontal and vertical axis and how things get mapped out here. So then it's once you figure that out, the strategic value of your applications, then you have the next step is, and these are some examples here, that how you would move these and which are some of the good candidates for moving to different models. So there are some typical examples we have seen in a variety of deployments we have done over the last 9 to 12 months or so. So CRM is a very popular workload, was one of the earliest ones to be hosted on public cloud providers. Development, testing, those are pretty good for deploying internally for your own development teams and groups, products, etc. And those are used for, one of the first candidates for private cloud if your IT organization is electing to build a cloud internally, and sometimes these can be moved to a public cloud also. That's where some of the large public cloud providers, they actually offer the dev test type environments. And then we have various IT applications with a variety of criticality that are virtualized. Some of these applications, depending on how mission critical those are or how custom those are, so are built on legacy architectures, sometimes of very high strategic value. So those are found on silos or being kept as silos. So again, these are some of the examples to get you thinking, figuring out what really fits in where, how it works, and what is a really good way to move going forward. So let's look at now public cloud part of it, right? So after understanding these concepts, the siloed applications and what really happens in there. So what we see is how do we take this and actually work out real details to make it all fit in together, make it all work, right? So depending on these deployments we have done, we are seeing customers running with it, a lot of our service provider customers working with it. The key 7 attributes that really stood out and really need paying attention to. And I'm going to walk you through these one by one over the next minute or so. So the main thing is cost effectiveness. So that has been the biggest driver. And what happens is as you start moving applications, looking at different deployment models, underlying storage becomes the most critical part, because what happens is while you are getting a tight handle on the server side of it and the application side of it, the underlying storage needs or requirements, they, in general terms, usually grow several times, if not order of magnitude. And that then defeats the purpose. So the main thing is that for a storage cloud, right, deploying it on storage cloud, the main thing is avoid the 2 attributes, avoid upfront storage acquisition or storage purchase costs. The second thing is avoid ongoing operational expenses. So basically pay for only the capacity used, right? So that has been a big attribute, that just use what you need and then pay for what you exactly use. The second thing is being highly available. And it's not just that your storage in the cloud has to be always available to you or always on, but what you need is also high performance to go with it. And that means that you have good bandwidth into it, you have low latencies of access to it, and also sometimes it means that you have complete data protection. So while you have your primary workloads in-house, having a DR or a data protection site out there, a backup site in the cloud, right? So that is evolving as one of the key and widely deployed models. The third attribute here is highly configurable. So every component of these public storage cloud, it not only needs to be monitored, but you have to also control it, configure it, and manage it, and being able to do that real time and not in a static manner where you get a bunch of capacity of storage, deploy some things, and that's it, but being able to manage that dynamically through self-service mechanisms, portals, those things. Then moving further down, highly scalable, right? So the network throughput and storage capacity, everybody looks at those that, hey, we need not only hundreds of terabytes, but now petabytes, even going into exabytes of storage, and throughput of hundreds of gigabytes per second. So looking at all of that, then we kind of start to get into things, and then we will walk you through many of these details and then actually show you how technology makes it all happen. But it's really getting it through Ethernet connectivity, being able to handle different protocol. We're going to really drill deep into a file protocol today, but blocks and HTTP also for accessing and delivering these enterprise cloud services. So that is very important. Then being measurable. So measurable is when you sign up and say, hey, I like it and I want to pay for what I use based on different things. Then being able to measure and monitor the resources used, right, and not just the bandwidth and the storage capacity that is being used, but also whether it is being used during peak hours or off-peak hours. The type of storage used, right? So the slow, high capacity, high density storage versus fast storage, right? And there are different levels of storage tiers. So based on all that, being able to measure that, being able to charge back based on that, that's extremely important. And being able to do that without a lot of overhead, right? Because the main thing is you want to use storage there for these services. So how to do that without lots of overhead on it. Then security. And security is not just keeping your data secure and what is going on there, but a key thing is especially looking at it from service provider perspective, that when you have a large shared infrastructure out there, right, storage, servers, networking, all these things, and you have a variety of things running on it, and then you are carving it out between multiple tenants and being able to do that securely, right? So every client or tenant that is accessing can only access its own data and not others' data. So that is pretty straightforward, but at the same time, while they are doing their work, running their workloads, accessing their services, they cannot impact other applications or other data of other clients, right? So that is also very important to watch out. And then the last thing is serviceable. So that is really being able to service the storage, especially data has to be always available, always accessible. So being able to make sure that it is serviced and serviced around the clock in a non-intrusive manner. Also can do it proactively. So before you hit a wall, before you hit a breakpoint or service level issues, outages, being able to see that come in, being able to kind of predict that and then avoid that before it even happens. So after explaining all of this, I'm going to quickly run you through some of the actual infrastructure, what happens there, some of the big data concepts, and before we take it over to Rainey to walk through the details. So this is a kind of a big slide. What it really talks about is that large amounts of data, and really huge, right? So this is large amounts of unstructured data, both in data set size and number of data sets. So we are not talking millions of files, but we are talking billions of files here. And the main challenges are that they just continue to rapidly grow, no control over it at all. And these are just huge pools of data. And these are globally distributed. These data sets need to be stored safely for long periods of time. And depending on different methods of access, we have to make sure the data sets are safe and they are retained according to the policies. And then the last one is the global collaboration. So collaboration across your organizations, across your locations and all of that. And that is really changing the nature of how data is created, managed, and accessed. And through these globally distributed sites, globally distributed users, different types of users. And then what that really all of this translates into is having a single namespace, one large container, auto balance across those, scale to billions of files, not just millions anymore, and then being able to access it from anywhere, anytime, through any mechanism. So moving on, what I'm going to talk about is NetApp storage grade product. And this is a product we actually acquired a company about a year ago. And this was the product based on that acquisition. So what it really is it's a very large content repository for large unstructured distributed data sets. and that's what storage grid is. And it was designed from ground up to really solve the big data challenges, the ones we saw earlier. And it is a large global content repository, manages unstructured data. It can store hundreds of millions of data sets and billions of files and petabytes of capacity. It also enables customers to create and manage and consume content globally. So what that means is it's completely independent of location. With location independence, you get all the benefits of having a local storage as if it's right there in front of you. And it does provide a truly global namespace across hundreds of sites. So that is one of the key features of this. And then it uses a metadata-based management for classifying data and access. What it means is it manages where data is physically stored, things such as how many copies exist for disaster recovery purposes, or how long these copies are retained, and when they are destroyed, and the policies around those. So that is really the key here. And the architectural principles behind these have been obviously reliability. And we talked about those 7 attributes before for enterprise and public cloud storage. So the main thing is it protects against site disasters, hardware failures, network, lack of network connectivity, data corruption, media degradation, all the usual things, challenges we face. It also has to be highly available for access from any location. So it is location independent with complete global object namespace. So that is what availability really means. And then scalability is not just billions of files and petabytes of data and hundreds of millions of data objects, but it scales in clients, throughput, capacity, geographic footprint, so location independent, and then multiple tiers of storage and time around it. So those were the architectural principles. It was based on some of the key functions behind it are the, as you see, data integrity. And what that means is as data is being put into the storage grid or the content repository, it continuously verifies it. It is self-healing, so withstands a lot of the common data corruption mechanisms as well as any of the failures that may impact data. So the other thing is policy-based object, and so everything is determined by policies and metadata. It is completely transparent to users and administrators. And then, as we talked about, you can access it from any place, any time, and any object across all of these tiers. So the thing here is, and we are going to drill, so these are different ways of addressing data. I'm not going to go through that. This is storage 101, how blocks are stored, how block level storage, where various data fields are put actually physically on locations on disk. And file is where we are going to spend most of our time. That is the most common form of storage out there. And what it means is every file has a name and is stored in a specific folder, and then there are file systems and they have limitations. So this really gets you past all that and billions or trillions of files, and how do you manage that and how do you organize that? And so instead of just providing a block-oriented interface that reads or writes fixed size blocks or data in a hierarchical series of folders or directories, what object storage does is it really puts data into flexible sized data containers. And those are the objects we've been talking about. And each object has data as well as a set of attributes. Those are the metadata. And then it identifies files and packages those along within the object. and then it can also allow data to be queried, get to it quickly, and then the indexing works around it. So that's what really allows it to scale. Otherwise, if you were to do it through a traditional file system or traditional block storage, LUNs and volumes concept, then that is not really a scalable solution at all, and that's what it does. So the main thing is the NetApp storage grid. It is really what you see here is that looking at all this. So first, applications, kind of the workflow, right? The applications write data to storage grid as to any network attached file system. When the data is written, there are two things that take place. One is it goes through the what you see here is that everything gets managed as a single entity. So whether it is public, so what you see through the middle here is depending on the policies around the data. That's where the multiple tenants, the middle cloud layer that you see there. So that allows it to manage as a single entity across scale across multiple tenants, each with their own policies and administrators. And it also allows storage to be organized into arbitrary storage pools for all of these, and then you can group those by tier also. So that's what you see out here. Here are several examples of different cloud services built on NetApp today. So different things, infrastructure as a service, data protection as a service, all across the world. So these are some of the biggest names in the service provider partners today. So they have been really deploying all of this technology and working closely with us. So everything I've been talking about is really based on solid deployments and history with these. And here is an example of one of these customers where it's a public cloud provider, very long history. And what they did is they did this with file archiving for static or inactive files. And they offered bulk ingest services where they could bring this data in. They put in a local appliance with NAS interface that talks with it, and data keeps moving seamlessly back and forth. And in the end, the value to customers is lower CapEx, reduced OpEx, and then really being able to save money on it. So now I'm going to hand it over to Rainey as to how the actual implementation takes place, how some of the key technologies and the integration that happen between NetApp and F5 to make it really all possible. Rainey?
Cool. Thanks, AJ. So it looks like NetApp has a really powerful cloud storage solution in this space. So I want to switch gears now and say, let's say that your organization is interested in deploying something like StorageGrid as a public or private cloud to augment your existing file storage infrastructure. Now, the things we're going to talk about are you're going to need a way to do so in a seamless manner because you have an existing file storage infrastructure, you have existing applications, existing users, and existing file storage systems. So we have to find a way to deploy the cloud so as to not disrupt your users and applications. So let's talk for a minute about how you're going to go about doing that. The way to think about cloud storage is really as just a natural extension to the basic concept of storage tiering. With storage tiering, what we're doing is we're matching individual files with the most appropriate type of storage. Now, this is not a new concept, and when we first started talking about this idea, the world was really divided into two buckets, performance and cost. If you needed high performance, you went with Fiber Channel. If you wanted to reduce costs, you went with SATA. Now, since then, there have been a number of new storage technologies introduced that each target different needs or specific pain points. For example, recently we've seen the introduction of solid-state drives. If you really need high performance, capacity optimization technologies such as compression and data deduplication to further reduce those capacity and data center costs. And finally, today you have the cloud. So the big question is, how do all of these technologies work together in your data center? In a simple view of the world, we can divide our data into two main buckets, right? Data that is active and changing, and data that is inactive and unchanging. The business value of our data is highest when it's first created, so we want to place these files on our high-performance storage. Now, as files become inactive and their business value declines, we can then migrate them to successively lower-cost types of storage, SATA, then deduplicated SATA, and then finally the cloud. So this introduces a couple of interesting challenges. First, identifying files suitable for any given tier, and then second, moving those files to the appropriate tier is a highly disruptive and operationally intensive task. What we really need is a way to tie together all of these disparate storage technologies, systems, and devices into a single namespace. But before we talk much about that, we need to first come up with a strategy to decide how we're going to match any given file to any given type of storage. And we're going to start with the bucket of cost, right? The cost of cloud storage is something that really isn't yet well understood today, so it bears talking through this for a little bit. Now, traditionally, storage tiering only considered the upfront cost of disk capacity. That is, how many dollars per gigabyte do I need to spend upfront to purchase a storage system, with, of course, the associated cost for vendor support and maintenance. Now, there's also another category of overhead costs, loosely labeled data center costs. So these include things like power, cooling, and floor space. With public cloud storage, public cloud storage doesn't just reduce these data center costs, but it actually offloads them completely to the cloud provider. So that's a really cool source of cost savings. Another consideration is utilization. Today, when you're running storage arrays at some percentage of utilization, you're typically running them at low levels of utilization. So there's an overhead, and this overhead directly increases your cost of not the storage capacity, but the cost of storing data. Now, with a public cloud storage service, you only pay for the amount of capacity that you actually consume. That is, the cloud storage provider manages its utilization on its end, and then charges you for the storage capacity that you actually consume, effectively at 100% utilization. Now, cloud does introduce a new cost that you didn't have to consider before, the cost of network bandwidth. Because you're transferring data over the WAN, you now have to consider a couple of new things, the cost of bandwidth out of your facilities, and if you're talking about a public cloud, typically the provider also charges you a per gigabyte cost for putting files into as well as retrieving it from their facilities. But by far, the biggest cost factor to consider with the cloud is operational. Studies have shown that the cost of managing storage over time far outweighs the cost of acquiring it in the first place. So think of all the migrations that you do on a day-to-day basis, all of the upgrade projects, the provisioning. With public cloud storage, all of that is offloaded to a service provider. So now, let's perform the same analysis with performance, that other bucket, right? Traditionally, performance basically meant the rate of data transfer that a storage medium could support. How fast can I write data to disk or read data from disk, how many IOPS, how much throughput, etc. Now, compression and deduplication added a new parameter, the overhead of optimization algorithms. For example, many companies actually won't turn on deduplication for their active primary data because of the overhead that deduplication imposes on file access, and instead they reserve it for their inactive data where performance may not be as important. And now, cloud introduces another parameter, network latency. You're now storing files at a remote location and accessing them over the WAN. Now, depending on the distance between your data center and the providers, there may be a significant amount of latency. And what this means is that at some point, your users and applications may see some performance impact when accessing files stored in the cloud. And then finally, we have data security. This is something that you didn't used to have to worry about too much, relatively speaking, because all of your data was stored under your control in your data center with access governed by your existing access control mechanisms. But now, with a public cloud storage service, you're talking about storing files over the public WAN, and in the case of a service, on devices managed by a third-party entity. So this now places a premium on data security, as well as an additional parameter for tiering. What files are you comfortable storing at a third-party location, and even for those files, what steps are you taking to minimize the risk? So given these considerations for performance and cost, it's pretty clear that we need certain capabilities in the file storage infrastructure that enable us to easily integrate and then tier to the cloud or any new storage technology for that matter. And we need to be able to do so in a way that maximizes the benefits while minimizing any additional costs, any performance impact, or any data security risk. So at F5, we like to talk about what it means to be cloud ready. And what we mean by that is the enabling of these capabilities so that your infrastructure is ready to move to the cloud when you are. So what are these capabilities? First, we need a mechanism to seamlessly integrate different types of storage, in this case, local and cloud storage, and we need to be able to do so in a way that is transparent to users and applications. What I mean by transparent is that users shouldn't have to go to one place for files stored on local devices and another for files stored in the cloud. They should have one location that contains all of their files, and behind it, the storage infrastructure intelligently manages where the files are actually stored. Second, we need the ability to move a file between local and cloud storage without impacting users and applications. This means that we need the ability to preserve user access to files regardless of where they're currently stored. And then third, as we saw in previous slides, we need the ability to move, to first identify and then second move only appropriate files to the cloud in order to minimize all of those extra network costs, performance impact, and security risk. And we need to be able to do so automatically so we, again, minimize the operational costs of doing so. So these are all capabilities that F5 can help you enable in your file storage infrastructure with our ARX series of file virtualization devices. Essentially, the ARX does two main things. At first, it virtualizes your file storage environment with a global namespace. What the ARX does essentially is it federates all of your underlying physical file systems and then presents that federated or virtual file system to users and applications. This means that instead of seeing all of those individual devices and file systems with some files here and some files there, client systems instead see a single virtual pool with all of their files in one place. Now, the ARX decouples the logical access to files from the physical locations where they're stored. The best way to think about this is as a proxy. Users and applications access files through logical file mappings presented by the ARX in the global namespace, and then the ARX proxies that file access to the proper physical location on backend storage where the file is actually stored. This proxy architecture is what allows files to be moved, storage devices to be changed, and the cloud to be introduced, all without impacting users and applications. The ARX hides all of that by keeping track of where the files are and always proxying access to the right place. Now, the second thing that the ARX does is it automates many of the common storage management tasks through intelligent data management policies, such as data migration, storage tiering, and capacity balancing. And we'll talk about all of these in the next few slides about how they come together to help you build a cloud-ready file storage infrastructure, as well as what their individual benefits are today, even if you're not yet ready to move to the cloud. But first, let's take a closer look at how this technology actually works, right? What I've heard from talking to a number of people is that the term file virtualization is really kind of abstract. So now I want to talk about how it works in a specific use case. A lot of our customers use ARX, for example, to virtualize their user home directories. So here we have a very simple environment. We have a single user, an ARX device in the middle, and a bunch of Windows file servers or any file storage device at the bottom. So with the ARX, the user accesses his home directory through a virtual CIF share presented by the ARX device instead of a physical share presented by the storage device. Now to the user, the ARX looks exactly like any other file storage device. The user sees all of his files as being stored in the virtual share, and he accesses all of his files through this virtual share. But in reality, behind the ARX, excuse me, the files are actually stored on a physical share presented to the ARX by a Windows file server. Now what the ARX does is it automatically proxies the user's logical access to that file through the virtual share to the proper physical location on backend storage. And then the ARX gives you automated policies to automatically move existing files or even place new files as they're created on specific storage devices based on automatic policies that you configure. So note that all of this is completely transparent to the user. all he sees is a single share through which he accesses his files. So now let's take a look at each of these capabilities of a cloud-ready file storage infrastructure and see how they can benefit you today as you're getting ready to move to the cloud, as well as tomorrow once you're there. And on this slide, we're going to start with the global namespace. The global namespace is essentially a virtual construct that hides all of the complexity of a disparate physical infrastructure from your users and applications. So think of a physical storage environment as a bunch of individual storage silos, in this case local storage and then cloud storage. A global namespace federates all of these disparate silos into a unified storage pool. And of course, the most immediate benefit is the ability to offer a single mount point or a single point of access to your users and applications, which simplifies file access. So with a global namespace, what we can do is we can create essentially a large workspace, right, a 32 terabyte, 64 terabyte, or whatever size workspace that stitches together multiple smaller physical file systems to meet whatever your needs are, right, the needs of your user home directory, for example, or the needs of specific applications. And when you simply run out of space, you simply provision in more capacity. You can even add in capacity, as we see here, from different storage devices, different storage types, or what have you. The next thing that the ARX does is that it allows us to migrate files without disrupting users and applications. That is, migrate files while preserving user and application access before, during, and after moving those files. Now today, this isn't so simple, right? Client systems are statically mapped to physical locations, and when you start moving files between different locations, you break those mappings, clients can't find their files, and you have downtime. So this is a huge mess, and this is one of the reasons why even small migrations take so much time and carry so much additional IT overhead, right? You have to spend a lot of time and resources planning your migration, moving your files at night and over the weekends to minimize the impact of downtime, and then manually fixing any errors that may have occurred after the fact, right? And you also have to reconfigure all of your client systems to access all of their new files at the new location. Now, with file virtualization, you'll recall that the ARX device presents users and applications with logical mappings to files through the global namespace and then proxies file access to the current location of those files. So this means that you can move files completely transparently at the physical layer because you never change the method through which they logically access their files. And this means that you can do away with most of that overhead that you normally have to do. You have to spend planning, fixing errors, and reconfiguring clients, allowing you to perform migrations with much less overhead and in much less time. So now, once you have the capability to move files transparently, without downtime, and without disrupting users and applications, you have this huge opportunity to start moving your files in a way that better aligns how you store your files with the priorities of your business. So that is what storage tiering is all about. When we talk about matching files to the most appropriate type of storage, what we're really doing is asking two questions. First, what is the value of these files to your business? And then given that value, what is the most appropriate way to store those files? What the ARX does is let you determine the business value of every individual file and then determine where that file should be stored, every file. So you can use the ARX to create automated policies to move individual files amongst different storage tiers based on file age, type, name, etc. And you can see on this slide that the global namespace really has two files in it, right? An active file, a moderately inactive file, and a completely inactive file. So although it appears to our users and applications that these files all reside in the same virtual share, in reality, the ARX has automatically placed them on the most appropriate type of storage for each file, depending on the business value of each file, and completely automatically with no IT overhead. And because of the global namespace that I talked about earlier, because it allows you to integrate different types of storage, including the cloud, now you can most effectively leverage each type of storage by customizing the policy that moves files to match the business value of those files with the characteristics of each storage type. So finally, I'd be remiss not to mention real quickly the opportunity to optimize the way you back up your data as well. So today, if you do full backups, you're typically mandated to back up all of your data at specific intervals and keep those backup copies for a specific amount of time. Now, the first problem is that every file system, as you know, has a combination of files that are actively changing as well as files that haven't changed in, say, a year or more. But if you do full backups, you have to back all of it up every week, even if the vast majority of your data hasn't changed from the week, the month, or the year before. So this is where the ARX comes in, right? Let's say you created a tiering policy that we described earlier that automatically moves files that haven't been modified in the last 90 days from Tier 1 to Tier 2. Once again, all of these files can be accessed in the virtual share, but now are split physically between different physical shares based on age. Now, you can apply different backup policies to different types of data. For example, you can continue backing up all of your Tier 1 data weekly, but because you know that all of your Tier 2 data hasn't changed in the last 90 days, you can back that up once a month or even once a quarter. Now, you can also do this based on files type. So let's say that you have different backup needs for PST files, for example. You can use the ARX to create a type-based tiering policy where all of your PST files in your user home directories are placed on a specific physical file system on the back end, and then you can back up that physical file system at a different interval. And then finally, the other way that the ARX helps with backups is by splitting large file systems into many smaller ones. So let's say you want to create a 16 terabyte file system, for example. If you were to try to back it up today, you might never finish because it takes so long and you have to quiesce the file systems, right? But if you have a 16 terabyte virtual file system comprised of 32, say, 500 gigabyte physical file systems, you can back up each of those 500 gigabyte chunks in much less time, as well as doing several in parallel. So if you're looking to move to the cloud, the ARX can really help you integrate different cloud storage offerings, such as NetApp Storage Grid, into your existing file storage infrastructure alongside your existing file storage devices. Not only does the ARX, as we described earlier, seamlessly integrate different types of storage into a single storage pool, it also allows you to migrate files between those different storage types non-disruptively and provides automated policies that automatically migrate files to the most appropriate type of storage. Tier 1 for active data, Tier 2 for inactive data, and then, say, NetApp Storage Grid for your really inactive data that you have to keep for a long time. Now, depending on the scale and performance requirements of your environment, if you're interested in the ARX, it's actually available on several different platforms, from the low-end virtual edition that you see here to the high-performance ARX 4000. Now, every ARX offers the same software functionality and capabilities, including everything that I just talked about, but differ in terms of performance and scale. So if you're interested in learning more about both the NetApp Storage Grid solution and the F5 ARX solution, we have a great white paper written by DCIG that actually covers both of them together. You can also go to the appropriate solutions page on both netapp.com and f5.com. And finally, if you have any questions after the fact, feel free to email either AJ or myself. And now I think we're going to open it up for questions. Rhiannon?
At this time, if you would like to ask a question, please press *1 on your touch-tone phone. Once again, it is *1 on your touch-tone phone to ask a question. It'll be just a moment for those questions to come through.
So while we are waiting for these questions to come in, so Rainey, excellent job on explaining all these things. So I'll get it started. So how exactly do you move files non-disruptively? Is it truly non-disruptive, or there are some disruptions that we need to watch out for?
So that's a good question. So obviously, there's, anytime you introduce a new platform, there's a small amount of disruption as we insert or deploy the ARX as it comes in to virtualize your storage environment. But after your environment's virtualized, as I described earlier, the ARX now functions as a proxy, right? So it proxies each individual file access to the proper physical location on the back end. So when we start moving files from one place to the other, the ARX keeps track of the file movement and actually hides it from the user, and then proxies that access to the right place.
Yep.
Any questions, AJ?
Yes, it does. And I see a couple of questions come in to the online Q&A. So one of the questions is, do you need an ARX at each location, both your on-premise and off-premise in the cloud?
Yeah, so that's actually a really good question. Typically, so before we started talking about the cloud, if you were replicating between multiple data centers, you would need an ARX at each location, right? Because if you were to fail over from your primary to your secondary data center, you would obviously want to have the same virtualized environment in both locations. But now that we're talking about the cloud, basically you would need the ARX only in your primary data center. So the ARX, when it automatically migrates files into the cloud through NetApp Storage Grid, for example, all of that, all of the management that's happening in the cloud data center happens through NetApp Storage Grid. So you don't need an ARX both in your data center and in the cloud data center.
Okay, that is excellent. So the next question is, can the ARX VE be used in production?
Okay, the virtual edition. So
yep.
It's a slightly more complex answer. So the ARX VE can be used in production and is targeted at low-end environments, smaller environments that aren't performance sensitive. So the reason that I'm kind of waffling for a bit is obviously it's a virtual machine. It runs on VMware as a virtual machine, and the performance is going to vary dramatically based on how overloaded that ESX server is. So, you know, if you only have the ARX VE and a couple other applications running on that ESX server, it'll run great. But if you have like 30 or 40 different applications running, yeah, obviously the performance is going to suffer a little bit.
Yep. So that makes excellent sense. So the next question is Data Manager able to query the cloud storage?
So this is obviously from somebody who is already familiar with F5 solutions. So Data Manager is a lightweight SRM, storage resource management tool, basically for file storage, and it allows you to run reports on, you know, different types of how your data breaks down in different ways, right, by age, by type, or whatever. So Data Manager basically is a local application. It can query the files in your cloud storage basically by targeting what's essentially a cloud storage gateway. That's essentially a local device in your data center that provides a local file system that front-ends cloud-based capacity. So in this case, it would be a component of the NetApp Storage Grid solution. Does that make sense?
Yep, it does. So another pretty interesting question here. So how does the F5 ARX device handle DR across sites?
So that's a good question too. So obviously DR involves multiple components, right, starting with replication. So typically the ARX relies on replication capabilities in the storage device itself. So in this case, for example, NetApp SnapMirror to make sure that all of your primary data makes it over to the DR site. So if you ever, heaven forbid, have a disaster, what we'll do is, you know, we'll fail over to the secondary site, spin up the virtual namespace, and then it basically looks exactly like it does in your primary site. So.
Yep. Very good. So yeah, so we are coming up here on the hour. So it's been really excellent. You know, I think both the interchange as well as the questions we saw. So any closing thoughts?
I don't know. First, I was going to ask if, Rianne, were there any other questions on the line, or did they all come through the web interface?
No, I do have a few questions on the phone. 3,
actually.
Okay.
Sorry about that, AJ.
Yep.
Your first question comes from Matthew.
Hello.
Hello.
I was wondering, with that DR that goes across sites, how would the clients be redirected to the DR site if the same subnets don't exist to that secondary location?
That's a good question. So typically, a lot of our customers use another solution like Microsoft DFS to automatically. That basically, it's just another DFS link on the back end that will automatically fail over to the other sites. So.
Okay. So we would essentially have to migrate clients to DFS, have DFS point to ARX as a target?
You don't have to. So we have customers with both DFS environments and non-DFS environments. So the ARX really looks like just another file storage device. So you'd really use whatever failover processes that you have in place to migrate to fail over between like one NAS device and another, to failing over between one ARX to another ARX device.
Okay, but in terms of DR, both ARX devices would be operating independently of each other. Would that be correct?
Yes.
Okay, thank you.
Yep.
Your next question comes from Francois.
Hi, I wanted to find out if there are any limitations on the type of OS used to access the storage on the cloud.
So are we talking about in the data center? Or are we
So if you want to access this, the shares, can Linux access it? Are there any limitations as to whether Linux can access these shares?
Oh yeah, absolutely. So the ARX provides, and I know NetApp Storage Grid also provides both CIFS and NFS access. So if you have Linux applications, Windows applications, even like Mac applications or clients, they can easily access all of these shares. It's just standard CIFS and NFS protocols.
Very good. Thank you.
Yep.
Your last question comes from David.
My question, I'm just curious to know how NetApp aware the ARX appliance is. So when it migrates the files to the cloud, is it able to migrate at the level or at the at the unit of a filer, of a NetApp filer, or is it simply just migrating files and the shares to the cloud, via CIFS and NFS?
So I think from now we're talking about different perspectives. From the ARX perspective, the NetApp Storage Grid is, as a public cloud storage provider, is just a target for. We basically migrate the entire files onto the NetApp Storage Grid solution, and then within the NetApp Storage Grid solution, AJ, you can correct me if I'm wrong. Basically, it'll handle, like where the files are actually stored in the cloud and what systems and things like that.
So it does all the back-end mapping. The Storage Grid does all the back-end mapping between the filers.
Yeah, exactly.
Right. Yep, exactly. Yep.
And
thanks. And we have one more question online here. Is there a way that third-party applications, for example, SharePoint, can see the data being stored in the cloud as read-only, so we don't have to be concerned with the metadata corruption from ARX or other places, things like that?
So that's an interesting question. So the ARX just essentially think of it as a data movement engine, right, or intelligent data movement engine. So we'll move files from one location to the other, but as long as that final location provides write access or leaves those files writable, then the ARX doesn't actually change anything on the file or prevent write access. I don't know, AJ, if the NetApp Storage Grid has that capability.
Yeah, we can. So we can set up, it's all policy driven, right? So some of the data can be actually marked read only depending on who's accessing it and so on. So yes, so actually it can be managed pretty granularly around that. Yep.
Excellent. That sounds really cool. Okay. Were those the only questions? Were those all of the questions in the web-based interface and over the phone?
We are showing no other questions on the phone at this time.
Okay. Well, once again, if anybody has any questions in the future, I'll flip it back to the slide. Feel free to email either AJ or myself. And AJ, it was great talking to you today.
Yeah, thank you, Rennie. Yeah, it was really nice.
All right, excellent. Thanks, and have a good day, everybody. Thank you very much for attending.
Yeah, thank you.
That does conclude today's conference. Thank you for participating. You may disconnect at this time.
Is anybody still on?
I'm still on. Are we in a private chat?
It went great.